Okay, now we are going to see the internal factors. Okay, internal factors. First one is age and number of leaves. Okay, so the age of leaf is very important, as well as number of leaves is very important for photosynthesis. Let's see. Uh, Aging of leaves actually is directly proportional to the number of chloroplast, because the too young or too old leaves contain very little chlorophyll. Okay, so as the age of leaves is gradually increased, the number of chloroplast formation also will be increased. So that's why I wrote here, aging of leaves is directly proportional to the number of chloroplast. And the if number of chloroplast will be increased, there will be more chlorophyll, and if there will be more chlorophyll, definitely there will be more photosynthesis. Okay, so too young and too old leaves is not better or best for photosynthesis. The best leaf for photosynthesis is the age of middle aged. Okay, so rate of photosynthesis in the middle aged leaves is the highest. Very important MCQ. And finally, the number. We can say the number of leaves is directly proportional to the number of chloroplast, right? So if for example, if in a plant 100 leaves are present, and if another plant 500 leaves are present, so simply you can understand, the more leaves, the more chloroplast. So in the second plant, the 500 leaves contain more chloroplast, and in the first plant 100 leaves is contain less chloroplast. So the more number of chloroplast, the more number of chlorophyll molecules, and the more number of chlorophyll molecules, ultimately the more photosynthesis. Okay, so we can say the age of leaves and the number of leaves is directly proportional to the rate of photosynthesis. As the age of leaves increased, and as the number of leaves increased, the rate of photosynthesis will be also increased. Okay, and there is another internal factor, and this is the amount of carbohydrates. Once again, see here, this is the carbohydrate, right? Glucose is a carbohydrate, and here if glucose increased, so definitely from this reaction we can say this is a product. So if the product increases in a reaction, then definitely the reactant will be decreased. That means if the product increased in a reaction, then definitely the process will be slower, right? And if the lower amount of product, definitely the process will be moving faster. So see here, amount of carbohydrates is directly proportional to the inversely proportional to the rate of photosynthesis. That means if as I told, if carbohydrates are increased, then the rate of photosynthesis will be decreased. Okay, and see here, if conduction or transportation of carbohydrates is low, then carbohydrates become clogged in the leaves, because the transportation of carbohydrates is become low. That means the carbohydrates will remain clogged, and it may cause like traffic jam of carbohydrate molecules. Then if carbohydrate molecules cannot pass properly, then definitely it will be clogged in different places of leaves, and ultimately the photosynthesis will be decreased. And in the evening there is high amount of carbohydrates, because through the day the production of carbohydrate, production of glucose occurs. That means in the evening very low amount of photosynthesis, or sometimes there is no photosynthesis in the evening. Okay, and there are another factors, and that is potassium. And amount of potassium is directly proportional to the rate of photosynthesis, because potassium plays as a catalyst of photosynthesis. So if potassium increased, then the photosynthesis will be increased. Another factor is the enzymes. There are lots of enzymes required for photosynthesis. So we can say enzymes is directly proportional to the rate of photosynthesis, because if enzymes are increased, then rate of photosynthesis will also be increased. Thank you.